Get all up in there.
All right, so let's find a second order Taylor approximation for f of x and y is 4 minus x squared minus 2y squared.
We need a point or not.
Okay, good. I need a base point. So where's your favorite base point?
Origin.
So why am I not giving you a z value?
That's it.
Because 1, we can calculate it, right? And 2, the Taylor approximation usually is phrased at around, right, one of the domain points, right? So here I've got a function of 2 variables, right? So this thing takes R2 and turns it into R1, right? So I get 2 dimensions, turns into a height. So here's your starting point in 2 dimensions. So what do you do? Okay, so your dumbest approximation, right, is just plug those in, get 4 out. Okay, so that's my which order?
0.
Yeah, this is your 0 order approximation, right? Which is really to say that's probably a bad approximation.
As if we're going to get on the test.
Hopefully not. Actually, that's worth something, right?
Unless you're like just super close, and it's like, if you're at like 0.000.
Yeah, right? Like sine
enough,
of
might as
things
well be.
near 0 is about 0, right?
Within 5 degrees.
Totally reasonable. Okay, where do you get the next piece of information from? Yeah, I need f prime, right? Which in this case is going to have to be both a x partial and a y partial, right? Okay, so what's your fx and what's your fy? Okay. Oh, what are those at 0? Okay, see that? So I'm going to get 0. What's your change in x? X minus your starting point, which is 0. Okay, that term was easy, right? That's 0. Plus, okay, 0 times y minus 0. Good. Okay, so here I've got the, right, this is fx evaluated at 0, 0 times delta x, fy evaluated at 0, 0 times delta y. Now I need the second order guys. So what's your fx, wait, which one do you want to do first? Okay, fxx is -2, fyy is -4, and pick your favorite, right?
X, Y.
X, Y, Y, X, whatever. Why doesn't it matter? Because they're the same, because...
It's continuous everywhere.
Yeah, this thing's a upside down bowl, right? It doesn't have any sharp spots. Cool?
Might sound silly and fun. But since they're the same, can you just times it by 2?
Yeah, and that's exactly what I'm going to do.
Okay.
Okay,
So
so
0 times 2.
what's my fxy?
0.
Is 0. So I don't have to worry about this a lot. But my next 3 terms, right, are going to be, this should be fxx evaluated at 0, 0 divided by 2 times change in x squared, right? Okay, so what's that?
-2 over 2
So I got -2 over 2
times delta x squared
times x minus 0 squared, right?
and then plus -4 divided by 2 times y squared
Okay, and then just for exercise, what would the other 2 be?
plus 0 divided by 2
So 0 over 2 times
x times y
x times y, right? Plus
0 over 2 times y.
0 over 2 times y times x, right? Or I could just multiply the 0 over 2 by 2, right? Cool. So all told here, what did I get?
4 minus x squared minus 2y squared.
Perfect. So I got f of x and y, right, is approximately
Is
4 minus
Minus x squared.
minus x squared.
2 over 2 is still 2. Good. Minus x squared. or
Minus
2 over 2
2y
is
squared.
1. Minus 2y squared. Oh, and this actually is f, right? Why is it f?
Same.
Because it's the same hour.
Yeah, I went out to the same order as I had powers, right, in this original polynomial. So if you start with a polynomial, big surprise, you'll end up with one, and it ought to be the same one.